Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about measurement of angles, converting angle measures between radians and degrees, and finding coterminal angles. All right, so we're going to take a measure in radians and we're going to convert it to degrees. By the way, you don't have to have a radian measure that has some value. In terms of pi, pi is just some value that you apply to a number. So whether or not a radian measure has pi in it or not is not significant. So we're going to take 3.41 and we're going to convert that radian measure to degrees. And what I'm going to do is I'm going to multiply the radian measure times 180 over pi because there are 1 pi radians in 180 degrees. So the first thing you want to do is you want to identify the radian value, 3.41. Then we're going to multiply the radian value by 180 over pi, and then we're going to write the correct answer. All right, so 3.41 times 180 over pi ends up being approximately 195.4 degrees, and then we're going to write the answer. Of course, we can have a radian measure in terms of pi. In this case, we have 5 pi over 2. 5 pi over 2, we're going to multiply it by 180 degrees for every pi radian. And then we're going to come up with an answer. So 5 pi halves times 180 over pi is equal to 450 degrees. And that's the correct answer we're going to write down. Right, the next step is for you to do some practice. So take a moment and handle these 4 practice problems, then come back and we will evaluate these problems. So take a moment, complete the problems. All right, so we've completed the problems. I have 2 pi times 180 over pi is 360 degrees. 11 pi over 6 times 180 over pi is 330 degrees. 5 pi over 3 times 180 over pi is 300 degrees. 5 pi over 6 times 180 over pi is 150 degrees. All right, so let's move on. Now we're going to convert degrees to radians. So 1 degree is equal to pi over 180 degrees, which means that for each pi measure in radians, they're 180 degrees. So we're going to take 1 degree and multiply it by 180, and we'll get, pi over 180, and that's how many degrees, or how many radians are in 1 degree. So we're going to start with 110 degrees. 110 times pi over 180 ends up being 11 pi over 18. And then if we want to evaluate using 3.14 for pi, we end up with 1.92 radians. Okay, so I want you to take a moment now and convert each of these degree measures to radians. All right, so we've converted each of these degree measures to radians. 180 times pi over 180 is equal to pi. 240 times pi over 180 is equal to pi over 3. 30 times pi over 180 is equal to pi over 6. 315 times pi over 180 is equal to 7 pi over 4. So again, if you're converting from radians to degrees, you want to end up with degrees, then 180 is in the numerator. If you want to convert from degrees to radians, then pi is in the numerator. So whatever you want to end up with, I guess in radians, you want to end up in radians, pi is in the numerator. If you want to end up with degrees, degrees is in the numerator. All right, so we're going to talk about coterminal angles, and before we get into that, let's go through a quick discussion of standard position. So standard position of an angle has the initial ray, which is this ray at the bottom, which is alongside the positive x-axis. And a positive angle measure would rotate the terminal ray, or the ray in which the angle ends at, in a counterclockwise rotation. So initial ray starts at typically at the x-axis. Terminal ray rotates in a positive fashion in a counterclockwise rotation. So terminal ray and then the initial ray form the angle. Of course, I can have a negative angle measure if I rotate the terminal ray clockwise, in a clockwise fashion, and then this angle measure would be considered negative. So now we want to find out what angle measures are coterminal with other angle measures. So coterminal means the same terminal angle. So we said we had an initial ray and a terminal ray. So we want two angles that have the same terminal ray. So in this case, 90 degrees is the angle, and we want to find an angle that's coterminal with 90 degrees. So we're going to add 360 degrees onto 90 degrees, and we end up with 450 degrees. So we can rotate the terminal array around 360 degrees and end up at 450, or we could also rotate this terminal array in a clockwise fashion, end up with a rotation of 270 degrees, negative 270 degrees, and end up at the same location as we would with a terminal array on the y-axis. So let's take a look at how that would look with some specific values. So let's take pi fourths as a terminal array. Again, the initial array is on the x-axis. And we're going to find our positive coterminal angle. So we're going to add 2 pi to pi over 4, and we end up with 9 pi over, I'm sorry, it should be 10 pi over 8 or 5 pi. Sorry about that, just caught a little math error. So it should be pi over 4 plus 2 pi is equal to 9 pi over 4. And then if we want to find the negative angle measure that's coterminal with pi over 4, it would be pi over 4 minus 2 pi, which is equal to negative 7 pi over 4. Right, so let's have you take some problems or some values and see if you can find coterminal angles, the smallest coterminal angle that's both positive and negative for each of these, and then I'll provide you with the answers, and then we'll be done. Right, so if I find the positive, one negative angle measure that's coterminal with 10 degrees, I add 360 degrees to 10, that's 370 degrees, or subtract 360 degrees from 10, that's negative 350 degrees. In the second example, I have 100 plus 360 degrees, or 470 degrees, or 100 minus 360 degrees, which is negative 260 degrees. Third example, pi plus 2 pi leaves me with 3 pi for the positive coterminal angle, and then for the negative pi minus 2 pi leaves me with negative pi for the smallest coterminal negative angle. Fourth example, pi halves plus 2 pi is equal to 5 pi over 2. And then pi halves minus 2 pi is equal to negative 3 pi over 2. And then for the last one, negative pi thirds plus 2 pi leaves me with 5 pi thirds. And for the negative angle, negative pi thirds minus 2 pi leaves me with negative 7 pi over 3.